In the last video, we ended up with one of our answers looking like this. X equals minus 8 plus or minus I times the square root of 17 over 2. It would be a reasonable question to ask, can this be simplified? And the mistake students would often tend to make, or do tend to make, is to selectively simplify. By this I mean 2 is dividing into both this term and that term. And so it would be wrong to do this. This would be wrong. It would be wrong to say that I'm going to cancel the 2 with the 8 and then write my answer as x equals to minus 4 plus or minus I times the square root of 17. And why is that? Well, again, 2 is dividing both parts. And you can't just simplify with one part without recognizing that you also would have to simplify with the other part. So that was, we covered this stuff in the fractions chapter, the rational chapter, simplifying algebraic fractions. We simplify by factoring these fractions and then canceling the common factors. So this is not canceling a common factor, it's canceling a common term. And so it's definitely wrong. And the method of simplifying these crazy radical expressions we're going to get for quadratic equations is really identical to what you learned in chapter 6. You've got to only simplify by factoring first, and then seeing if you can do that, then you can finish. So let me give you a couple of examples of simplifying when you can simplify. And incidentally, this answer could not have been simplified. So, all right, so suppose we get this kind of result. X equals to, let's see, 12 plus or minus the square root of 18 over 6. All right. Well, another common mistake is to cancel the 6 into 12 and into 18. And here's the problem with that. The square root of 18 divided by 6 is not the same as the square root of 3. And why? Because 18 is a square root number. I mean, this is a square root number. 6 is not a square root number. So they have basically different exponents. You can't mix those in with division or this way. So, but we can simplify the square root of 18, and that may lead to something. So let's see that. See what happens here. The square root of 18 is the square root of 9 times the square root of 2. And then the square root of 9 is 3. So I simplified this square root. And now 12 plus or minus 3 square roots of 2, these both terms have a common factor of 3. So we can factor a 3 out. This equals to 3 parentheses 4 plus or minus the square root of 2 over 6. So we factored the common factor of 3 out. And now you see that this factor of 3 cancels that factor of 6. And we end up with x equals to 4 plus or minus the square root of 2 over 2. So you think, well, can I factor the numerator anymore? No. Well, then we're done. We're finished. And again, don't fall for the trap, because it looks like you can cancel 2 into 4. And some people might think you can also cancel this 2 into that 2. Can't do that, because 2 is dividing both, and 2 will not divide into the square root of 2 and produce the square root of 1. It's just a mistake. So, in fact, let me hammer that home. If I said, well, I can divide 2 into 2 and get 1, the square root of 1, well, the square root of 1 is 1. But what's the fallacy there? Well, these numbers are unequal. This is about 1.414. This is 2. that number divided by 2 is never going to equal to 1. So again, I like to point out the common mistakes people make, and really I'm kind of convinced that people who make those mistakes are the students who really don't do any practice or very little practice. Please, I know it's late in the quarter if you're watching this video. If you think you understand what I'm talking about here, what you saw in my book, you really don't understand it until you can do it on your own. And so it's very easy to make these mistakes when you don't practice and check your answers. All right, one more example here. Let's see, how about just for the practice, let's look at an answer of x equals 2. How about, give me a minute here, 10, negative 10, plus or minus the square root of negative 50 divided by 2. Okay, well, we can do some simplifying here. And the square root of negative 50, for starters, is a complex number. So this would be negative 10 plus or minus I times the square root of 50 over 2. So there it is, written as a complex in complex number form. Let's see about that square root of 50. The square root of 50 is the square root of 25. And don't forget the I, like I was started to. So it's I times the square root of 25 times the square root of 2. Everything is divided by 2. And so this becomes a 5. So x would be negative 10 plus or minus 5I times the square root of 2 divided by 2. So that's simplified. I can factor a 5 out of here, but the 5 that we could factor out would not cancel with the 2, so that would be as far as we can take it. Now, suppose that I had given you this problem. Suppose that was a 20 instead. All right, so new problem. It's the old one with a 20 down below instead of a 2. If that was the case, then we would factor the 5 out. And that would leave negative 2 plus or minus I times the square root of 2 over 20. And now we can cancel the 5 with the 20, leaving a 4. So in that case, we can go a little further. X equals to negative 2 plus or minus I times the square root of 2 over 4. And again, that doesn't cancel because we can't factor 2 out of the numerator. So this is as far as we can simplify. All right, I do want to give you one more example I just thought of. So one more quick one here. And this happens when, as it turns out, it happens when people are solving problems that could have been factored. They could have been solved by factoring, and they'll use the square root method or the quadratic formula, which we're getting into next, and fail to finish simplifying. So here's a typical example. Suppose you had this answer from the work you've done. X equals to minus 1 plus or minus the square root of 3 over 2. Oh, I'm sorry, I meant to make this a square root of 9. All right. Negative 1 plus or minus the square root of 9 over 2. Well, what can we do? Can we do anything? Of course, the square root of 9 is 3. So this is negative 1 plus or minus 3 over 2. Do you stop there? I hope not, because we can combine these numbers now. They're not both square, neither one is a square root, they're just integers. So let's write out both answers. It's negative 1 plus 3 all over 2. and negative 1 minus 3 all over 2. And so this gives us negative 1 plus 3 is 2, 2 over 2, negative 4 over 2. So our answer would be, simplifying these fractions, 1 and negative 2. So there we go. Go the distance. I expect you to simplify as far as you can. And if the square root totally disappears, then you definitely will have some more work to do to get it down to a final result that's simplified.